So sketches are 2D profiles which we use to create 3D features, okay? Or at least for most of the 3D features, not all of them. For most of them, we need 2D profiles, okay? We call them sketches. In SolidWorks, there are two types of sketches, 2D and 3D. We mostly work with 2D, but I told you sketches are 2D, but there is actually one category. These are 3D sketches. And they are not as frequently used as 2D sketches, but when I say 3D sketches, basically means 2D sketches where you can change the plane of the sketch when you are drawing it, okay? So first you start on the XY plane, and then as you go forward, in the middle of the sketch, you change your plane to XZ plane and then YZ plane and so on, okay? So still you are drawing 2D sketches, but you are able to change the plane of the sketch. That makes it 3D. So we'll talk about 3Ds a little bit later, but what we want to focus right now is 2D sketches, okay? To draw a 2D sketch, you need a flat surface. We call them a plane. When you start SolidWorks, there are three default planes, front, top, and right. But SolidWorks gives you, like many other software, gives you the option to create customized planes, okay? So let's get started and I'll show you. So this is our SolidWorks here, right? And we do a Control N, and then we start a new part. As I said in the beginning, you have these three planes, right? Front plane, top plane, and right plane. And you can draw on any of them that you want, or you can create customized planes. So if you want to go on any of these, all you need to do is just do a one left click on them. And then you get this menu, and all you need is to click on the sketch command. Or if you are under the sketch tab, once you click on them, you go under the sketch tab and then click here on the sketch. That's the same thing. If you do it, then the view will change in a way that it is now normal to the front plane, and now you can use the tools for the sketch toolbar and basically draw almost any shape that you can imagine, right? And I'll go through them. Lines, circles, anything, right? So I can click here, center it at origin, draw a circle, I can create a line, right? I can keep drawing the lines unless I'm done, until I'm done, and then I use escape to turn it off. I can use rectangles, I can use polygons, I can use elongated holes, right? There are so many things, arcs, you can use ellipses, conical sections, and so on and so forth, okay? So there are so many things that you can do, and we'll go through each and every one of them and I'll explain. Okay, so this is if you want to do it on one of the default sketches, and when you're done, you can just click on this guy and close the sketch. And then you can use them. Of course, you cannot use this. You have to have one closed profile or several closed profiles, not something like this. Then I can go under Features tab, I can extrude them, revolve them, do loft, do sweep, and do so many other things and create 3D features. But as I said, you can also do these on customized plane. If you do not want to start right on any of the three planes, I'll show you where to add a customized plane. By the way, that sketch that I made is now all under here, okay? If you see now, one item is added to the tree. It's called sketch 1, which is all of these guys. And you can go back and modify it, right? All you need is you right click on it and then click on this top left corner which says edit sketch, and you go back here, and then you can just like highlight anything, you can delete them, right? So I'm highlighting anything by just clicking on them or drawing a rectangle around them. Once they are highlighted, I use delete from the keyboard and get rid of them, right? So that's it. And if I click on that cross, then it discards my changes. If I click on exit, then it keeps my changes and exit the sketch. So here, that's my sketch. And now if I want, I can delete the sketch. Let's say for the moment, right click and delete it. Now, as I said, let's say I don't want to create anything on the front plane. I want to create something on a plane that has offset with respect to front, is parallel to it. So what do? I go under the Features tab, right? You see there are so many tabs. I go under the Features tab, and then I go under here. It says Reference Geometry. I expand it, and then I choose the Plane command. And now it gives me options. You can choose up to 3 references to define the options for your plane. You can make something parallel to something, coincident, which means on the top of that, perpendicular to that, at angle, offset. You can create a plane between the 2 planes. We call it midplane if you have. So let's say here I want something that is parallel to this, right? And then you can here click on this distance, offset distance, and provide the distance, right? I want it 3 inches off from the front plane, right? Now I can, on this new plane, which is called plane 1, and you can see it under the tree, on plane 1 I can left click and go to what? Go to sketch, right? So this is offset from the front plane, yes? So now I can do whatever I want here. Right? And if I don't need to see those planes, because if you see the front plane, top and right are hidden, right? So when you click on them, they appear, but they are hidden. You can show them if you want. You can make them visible all the time. You right click on them and show them. But by default in SolidWorks, these planes are basically hidden in the beginning so that they get out of your way, right? Now this plane 1 also, this guy that you just created, this is also visible when you make it, but you can what? You can right click on any of these planes that you do not need to see anymore and just hide them, okay? All you need is the sketch, not the plane mostly. So you can just use the sketch, and then as I said, you can go to extrude and then create objects and so on and so forth. So we'll talk about that. But whatever plane that is on your way and is occluding the other objects, just right click on it and hide it. Good. So this is one way to create a what? To create a customized plane is that you basically do offset, right? So this was the front plane and I created a plane with offset with that, correct? You see? Now I can do more options, right? I can, for example, click 2 planes and then create a plane in between the 2, mid-plane, right? So I go here and then I say I want this one and then I want this one. And then by default, it offers you a mid-plane, right? So you can have a mid-plane. So now this one, if you look from the side view, this is exactly in between the 2, right? And you can draw something on that. Or you can do basically perpendicular plane, angle plane, anything like that. So let me show you a couple of more options. So let's say now I want to create a plane that is at angle with plane 1, correct? And the axis of rotation is any of these lines or anything perpendicular to that plane. So I go here and say, well, I want this to be my reference, but not parallel, I want perpendicular. Okay? And then it says, okay, perpendicular in which direction, right? So if I do say okay, it's not going to accept it because you have to say in which direction perpendicular, because you know there are infinitely many planes that are perpendicular to plane 1, right? Which one of them? You have to have an axis of rotation. So your second reference will be your axis of rotation, okay? If you choose this, then look, it is going to be a plane perpendicular to that, but that plane passes or includes this line. So not the axis of rotation, it is passing through that. Or if you want, you can make it at angle instead of perpendicular. Say, no, I don't want it 90 degrees, I want it like at 30 degrees. Okay, So again, your plane is at 30-degree angle with plane 1, and it passes through this line. If you have a line perpendicular to this plane, then you can use it as axis of rotation or something too. So that's the way to create so many different planes. If you have like 3 points, then you can pass through these 3 points a plane, right? So for example, let me go on this plane and then just create a point and get out. And now look, I will create a plane that passes through this vertex and then 2 of these on this basically heptagon. So I go here, go to plane, click on here, my first one, second one, and then what? Third one. This plane is defined by these 3 points, right? So there are so many ways you can create customized plane, and we'll go through many of them throughout this course. So just want you to know about some important ones. So creating customized plane, I talked about it, how to get into Sketch and get out of the Sketch, right? So I talked about you choose a plane, you click on the Sketch command, you go in, and then you can what? You can close the Sketch, you can discard the changes to Sketch, and you can edit the Sketch, right? So I mentioned all of that. Let's say here I want to create these 2 concentric circles on the front plane. So I go to front plane, and then I click on the Sketch command. Then I draw 2 circles, one here, and then another one again centered at origin like that, correct? So there we go. Yes? Now, if I want to keep what I made, I click on Exit Sketch, right? So I have them in an item called Sketch 5, and they are stored there. If I want to go back and edit that, I right click on it and go to what? Edit Sketch. So I can now go back and modify it, right? Now, if I again click on this, it will save the changes that I made. If I click on this, it will discard the changes and act as if I have done nothing. Look. You see, it went back to the previous one. It discarded my new changes. So discarding new changes, exiting and saving them, right-clicking and editing the sketch, and choosing a plane, and then going to Sketch and creating a sketch. So I guess I have talked about all of these items. Let me bring this up here into the lecture. Okay, now let's talk about, and as I said, I'll talk about 3D sketches later, but let's talk about the 2D sketch entities, these guys, different things, different shapes. Let's talk about them and see the application of each one and how to use them. So here, as you can imagine, starting from here, line is quite obvious. You just click and then what? Draw a line from any point to another point, right? And then this command does not turn off, so you can keep drawing lines that are connected to the previous one, right? So you can draw a profile. Well, that's what we call in CATIA a profile. And then you can draw, keep drawing, and then if you want, you can close the profile. If you close it, then still it's on. You can draw more. Now, if at any point you are done, you either click here and turn it off, or if I want to turn it off at here, as I said, either you click on the command or you use escape from the keyboard, okay? That will shut the command off too, okay? So that is a very useful thing, escape from the keyboard. So this is the command line, very obvious. Now underneath that, you have center line and midpoint line. Okay, so for midpoint line, so let me draw a line here. You see? What happened is instead of, look, when you click on line, you have to click on first point and last point, right? The two endpoints. While the midpoint line, you don't click on the endpoints, you first click on the midpoint of the line, and then what? Symmetrically from the midpoint, you continue in one direction, and so the distance between the endpoints and the midpoint is of course the same, right? Because that's midpoint. So you just choose the orientation and the length of the line right now by clicking at somewhere. There we go. Yes, so if you know where to draw the endpoint of the line, you use this one. If you know the midpoint of the line, you use that one. The other thing you have is a construction line or an axis, okay, a center line, which basically it's a dash dotted line, and we use this for many things, okay, including for doing mirrors, and I'll show you. When you want to do a mirror, as you can see in this picture, you need a center line, okay, and I'll show you that. So these are different ways to create lines. Now you have circle, so the basic circle, which is you click on the center first, and then by clicking on one point on the circumference, you determine the radius. That's one way. The other way you have is premature circle. So instead of knowing the center and the radius, you just know that this circle has to pass through 3 points, point 1, point 2, and point 3. Okay, so you don't know the radius, you don't know the center, you just know 3 points on the circle. And I'll show you the application of this. Actually, this one can be really useful. So we mostly use the center circle, but this perimeter circle can also be quite useful. Then we have Espy line. So Espy line is basically a continuous, smooth curve that passes through a bunch of control points that you click on. So I click here, then I click here, then I click here, here. So I keep clicking, and it just passes, right, a smooth, continuous curve through all of these points that I click on until you go back to the beginning point and close it, or use the escape from the keyboard and turn it off. Okay, so it will give you smooth, continuous curve. Now, what does that mean? Continuous is quite obvious. It means that when you want to draw it, you're not going to remove your pen, so there is no jump, no discontinuity. But when I say smooth, what does that mean? It has a fixed mathematical definition. Okay, so we call a curve smooth. Anybody knows what smooth is, hopefully. You learned that from your calc courses, that if I have a function and this function is passing through a bunch of points here, so right, so it is an Espy line like this, and I call this f of x versus x, right? So first of all, this Espy line is not one single function. It is a collection of functions. In other words, between each two consecutive points, there is one function. So between point 1 and point 2, there is one function called f1. Between 2 and 3, there is another one, f2. Between 3 to 4, f3, and so on and so forth. Okay? So if you have n points, there is n minus 1 functions that are connecting these points together. So it's a multi-criteria function. It's not a single function. That's first of all. Second of all, what kind of function is each one of these? When we say polynomial, is it polynomial? Is it a circle? Is it an ellipse? Is it what? A sine or cosine? So all of these f's are, in general, polynomials. And typically, not all of them, all the cases, but typically they are cubic polynomials. Okay, that's why we call them, these curves, these functions, we call them cubic Espy lines. Which means like f1 of x is like this. a0 plus a1x plus a2x squared plus a3x cubed. All of them look like this. The only difference is the coefficients are different for each one of them. So actually, in this case that you clicked on 6 pointer, you have 5 functions. There are 5 functions. Each one of them has 4 coefficients. So SolidWorks, just by you clicking on this point, SolidWorks in the background has to calculate all of these coefficients for you, right? So if you click on n points, then 4 times n minus 1 coefficients have to be calculated. Okay, so there is a code behind the scene that calculates all of these coefficients, right? Because there are n minus 1 functions, each one has 4 coefficients, so you have those many coefficients to calculate when you're just simply clicking on them. And now, how does SolidWorks calculate them? So I said this curve has to be continuous, correct? And smooth. What does that mean? So let's look at them mathematically, because I don't want this class to be just all drawing sketches. I want you to know detail behind every one of these things. Why? Because I found that in the past we had a couple of our students or more that went and worked for these CAD companies. Actually, one of our previous students, she's right now working for Dassault Systems, the company that is making SolidWorks and CATIA. So she has to know what's going on behind the scene, right? Because you have to write the code behind the scene to do all of this. So it's always good to know what your software is doing and not just consider it a magic box. So for example here, as I said, if I call this point like point, whatever you want to call it, point x2, right? Let's say this is x1. So if I call this point x2 an intersection point, then for continuity, I need to have f1 at x2 to be the same as what? f2 at x2, right? The value of these two functions at the intersection point has to be the same. That makes this curve continuous at x2. And then a similar condition for 3, 4, and 5, right, at the intersection point. But when I say smooth, what does that mean? So smooth means the derivatives at the point are the same. So the first derivative of f1 at x2 is the same as first derivative of f2 at x2. In other words, the left and the right slope of the point are the same. There is first derivative at that point, okay? And also the second derivatives of these functions at the intersection point is the same. Second derivative in calculus means what? Curvature. So the curvature of this curve and the other curve are the same, okay? And you can show that the rest of the derivatives are all going to be the same at this point, but we just need 2 of them. So smoothness and continuity. So you have here how many conditions? 3 conditions just at that point. Okay, so each one of them will give you 3 conditions. So in this case, you have 6 points. So you need, in general, 4 times n minus 1. So 4 times 5, 20 coefficients. Now, how many coefficients will you get, really? So here, again, I need 20 coefficients. So I need to have 20 equations. Do I get them? Well, here, that's 3, 6, 9, and 12. I only have 12 equations. What about the rest of them? I need 8 more. Where do I get them? Well, the value of f1 at x1 is determined, right? Because you click on that point. So if you call this value y1, you also need to have f1 at x1 to be equal to what? y1, right? Or f1 at x2 equal to f2 at x2, and this is equal to what? y2, because you clicked on that point. And similarly, f3, f4, f5, and f6. So there are 6 values of y that you clicked on, and those give you another 6 equations. Now 6 plus 12, 18. I'm still missing 2 more equations in order to solve this whole problem. Where do I get those? Through the slope of the first point and the last point. So you either go with natural splines or what we call clamp splines. There are several different splines. In natural splines, you set the curvature at the beginning point and the curvature at the end point to be equal to 0. So if you say f1 double prime at x1 is the same as f5 double prime at x6, and this is equal to 0, that gives you 2 more equations, and we call the resulting spline natural spline. If you set the initial slope, you say that's my initial slope, that's my final slope. If you say no, instead f1 prime at x1 is equal to some a that you determine, and then f6 prime at x6 or f5 prime at x6 is equal to b, then again b I will determine. That is another way to get 2 more equations. We call it clamp spline. Okay, so you need the 2 end conditions. Now you have to solve it to any system of unknowns and equations. Once you know all of this, then you can draw those curves. Okay, so although it looks very simple, just you click on a bunch of points and it draws something, but behind the scene there is a lot of math going on. So just wanted you to know about that. Good. Now, you might wonder, okay, where do I use this in real life, right? Good, you know all the math, now I know how to use it. Where in real life you think you would use an spline? Well, one application for aerospace engineers is what? Yes, the airfoil. The airfoils of airplanes, right, the wings, are actually typically 2 splines, one on the top and then one on the bottom. Now they are typically way more complicated than what I'm drawing here for you. Okay, and they typically pass through several hundred or even 1,000 points to make them accurate splines, and they are calculated mathematically. Okay, so here I'm just showing you a very simple case of an airfoil. And you can also change the shape of an spline by grabbing any of these endpoints and just moving it. So if I hold down left mouse key, I can what? I can easily reshape my spline. Okay, so you can just drag and move your endpoints and reshape your spline. Sometimes you might find that you needed more control points. Instead of just this few, I needed a few more to get exactly the shape that I want. What should I do? Should I redo it, or is there any way I can insert, let's say, control point between these 2? Yes. You just right click here on the spline and then say what? Where is that? Tangency control, curvature control, no, here, insert an spline point. Okay, and now wherever you click, it will add 1 more point over there, here, right? Look, you see, I have added 1 here. Or let's say I want 1 here, right? So I just right click, insert an spline point, and there we go. Here, right? And now you can do more local control. Okay, so Espy lines are really good. We use them a lot in real life, and one prime example for aerospace students is an airfoil of the wing. Okay, rectangle. So the rectangle by default is this one, which is called corner rectangle. So I click on one corner and then drag it to the opposite corner and click, and that will give you a rectangle. So that's one way, corner rectangle. The other way is if you know the location of the center, then you can do center rectangle. So I know the rectangle is here, center, and then I draw it to one corner and then I click. Yes, so that's another way to do a rectangle, corner rectangle or center rectangle. Okay, so we also have 3-point corner rectangles and center rectangles, and these are used when your rectangle is not basically having horizontal and vertical edges, right? So it's rotated. So the first two commands just create a rectangle with horizontal and vertical edges, but the next two commands will basically create a rotated rectangle. Okay, so here you determine basically one direction, and then you determine the amount of extent. Okay, and then the last one is, of course, parallelogram, right? So these are different things you can do under the rectangle command. Then we have arcs. You can have a center point arc where you have the center and then the angle in front of the arc. So that's the center. This is the radius, and then from any point to any point you can have an angle, and you can see the amount of angle is shown here, 50 degrees, 60 degrees, and so on. That's one way. The other way, which we use a lot, is 3-point arc. So that's where you have the two endpoints of the arc and then another point on the curve. Okay, this guy is used a lot. And we also have tangent arc. Okay, so if you have a line and you want to draw an arc tangent to it, you can use this command, although if you just do an arbitrary, so let's say here, instead of, let's say I have this line, right? Okay, so if I use that command, I could make this curve to be tangent to this, although I can do it later on too. So let's say here I have this one and this one. I hold down Control, do a multi-select. I select both, and then I choose the option tangent, and I force it to be tangent. So I can directly use this, which automatically adds the tangent, and you can see the symbol of tangent for me, or I can add the constraints later. Then I have the conic sections, including ellipse, partial ellipse, parabola, and this general conic, which could include hyperbola. So if you want the ellipse, click at the center, then determine the semi-major radius and then the semi-minor radius. And you can have your ellipse. We have elongated hole, which is a really good tool for creating many parts. Okay, so you determine center to center distance, and then you determine basically the radius of the arcs, or the width of the part, or the height, actually, the height of the part. So this is the straight version. Then we have a centered version of that, and so many other things. Okay, so these are quite nice commands, and we're going to use them. So here you determine the radius of the circle passing through the center of the circular hole. Then you determine the end-to-end point, and then you determine what? The amount of radius, and then you get this kind of kidney bean shape, right? You have the polygon, which first you determine how many sides you want, right? You want 6, 8, 10, you can go from 3 to any number. And let's say I want a hexagon, so I click here, click at the center, then determine basically the size of the hexagon, and there we go, right? And if you move your mouse around here, you can determine also the orientation of the hexagon in addition to the size, or any other polygon. We have the point command, so this is for points. Where would you use a point? I'll tell you later. It has a bunch of applications. We have, of course, fillet and chamfer. These two options are for basically getting rid of sharp corners, right? So if I click on fillet, then I can round the sharp corner. So I select the two edges leading to the corner, and then I provide the amount of radius of fillet, right? And there we go, right? I rounded this sharp corner, or I can cut it with the straight line. I call it a chamfer. So I have this one, and then I provide distance, or distance angle. So I say the diagonal line is, let's say, 3-4 inches, and the angle is 45 degrees. And let's see, here I guess it didn't update it. I can update it here, or I can redo it. So I click on the command, I provide my numbers, let's say 3 inches and 45 degrees, and then I select them, and that is the chamfer, as you can see here. Okay, maybe that is a little bit too much. Okay, so let me make this like an inch instead of 3. Right, so you see that sharp corner that was here is now cut by a plane at angle, right? So that way of reducing sharp corners with a little milder slope, we call it chamfer. That used at the bottom of bolts, if you probably have seen, but fillet is mostly used to get rid of sharp corners. Why do we get rid of sharp corners in many applications? First of all, sharp corners and sharp edges, as the name says, they are sharp, so they can cut the hand of the operator. The other thing is if they are internal edges, okay? So edges like this. So the part profile is concave. So if you have a corner like this, and then you basically extrude it and convert it into an object, then at that location you will have something that you probably have heard or will hear about. It's called the stress concentration. Okay, and I guess our dimensions are quite large. Let me change that to a bigger number. So if you put this part under pressure or under loads, at this point the part is going to be weak, and it makes the part actually fail quite easier and under a smaller load compared to something that has this part filleted out. So this part with the sharp internal edge will fail far easier than if you just basically applied a fillet here, right? Okay, and you probably have heard that if you pass solid mechanics. If not, you will pass that course and you'll hear about stress concentration. And if you do that, that makes the parts endure more pressure, more load, and have a larger, longer lifespan. And the other thing is, if your part is to be made by like CNC machines, so CNC machines, they always have a radius of a tool. And so when you want to go around and create basically the part, you can not really create super sharp corners like this with a CNC machine, okay? So for example, if I do a cut on this so that you can visualize what I say a little better. So let's say you have a part and then you want to cut something like this out of it. Right, you have a pocket like that. So if you put this part in the CNC machine can never give you a sharp corner like that. It's not possible. you always have a small radius, and that is equivalent to the radius of the tool that is cutting this for you. Okay, so if you make it already with some fillet, that is way more realistic to what the machine can give you back, the manufacturer can give you back. So do not expect something like that to happen out of a CNC, to come out of a CNC machine. Sharp corners are not doable in a CNC machine. So that's some of the things I mentioned about fillet and chamfer. The other command that is actually very useful is text. You can basically type anything that you want. That is extremely useful for many applications. In CATIA, you don't have this option, and when you want to add some text so that you can make your own logo or anything on the part, that is not available directly in the sketch and makes life very hard. So here, let's say you made this sketch and then you used it to create some parts of your own, and then on this part you want to add the logo of your company, right? So you go on this top surface, you create a sketch, and then you want to write something here on a line or on a curve. So you go and use basically a line, right? A center line. It has to be a center line. And then you use the text, and now it uses this line to write on, right? Because when you want to write something, you have to write it on some curve or line, right? You have to tell it what curve or what path to follow. So here you see I have chosen this line to write on, and then I write whatever I want. So I call it my logo, right? And now this is quite small, so I can make it way bigger so that you can see it. And I go to font size, right? So the typical font size, I first choose the text. I can make it bold, italic, anything. I can flip it vertically or horizontally. I can make the letters wider. I can make the gap between the letters more. And then if I don't want the default document font, which is too small right now, if you can zoom in, that's just that small. So if I want, I can make it a lot bigger to visualize better, right? So you see, I can make the gaps bigger, can make the letter wider, and then I uncheck this one, says use document font, and then go to font. Then under points, I can change the number of points from, let's say, 13 to 72, or even I can type bigger numbers, like 1 to any. Okay, so I can make my text a lot bigger. If that's still small, type in bigger numbers. Let's say I want a 400. Okay, so now you wrote some text, and now you can use this text as a sketch, and then you can basically give it some extrusion, right? Here we go. Here. So you added the logo of your company. You basically embossed it, right? Or if you want, you could deboss that and cut it in. Okay, so I have the text, and then I can use cut extrude and then cut it in, called deboss. Okay, so this is a very, very useful tool, this text, for adding text to your CAD parts when you want to manufacture them, the logos, anything, decals. So I guess I went through all of the basic sketch entities that we have. Then I have to talk about the rest of them, and I will. But before I go any forward, I want to talk about one important thing, and that is called construction element. Okay, so let's talk about that, and then the grid. So I'm going to talk about these two before I talk about the sketch tools. So construction elements are the elements that are not considered a real part of the sketch. They are just there to help you draw the basic elements of sketch. Okay, so they are just auxiliary, helping, but you cannot use them to, let's say, create 3D objects, right? So as I said, one of them is a center line. So when you want to mirror something, you can use a center line, or anything like that, okay, as long as they have this type of dash dotted shape instead of solid, their construction. So let's say here, for example, if I go to sketch, and so the only thing you have right now is just a center line that is dash dotted. Everything else looks solid, but you can convert them to a construction element. Let's say, for example, if you remember the text, you have to write it on something, on a line or a curve or something, right? So let's say I want to write something and then extrude it. So, and I want to write that text not on a line, I want to write it on a curve. So I use the 3-point curve, and then I draw an arc. And now I want to write something on this. But since I don't want this to be a part of what I would extrude, I need to convert this just to basically a guide element, an element on which the text is written. So you see, when I drew this, if you look at this window on the left, under options, there is this box here says for construction. If you check that, now you see it is gone to dash dotted format, and now it's not really something that you can use for any purpose other than helping the other elements, right? So if you exit the sketch, okay, you cannot do anything with this. But I can use it. Let's say if I go back, I choose this, and then I go to text, and now whatever I write, it will be written on this arc, right? So this is a demo, right? So I can write it on this, make it bigger, make them wider, and the gap bigger between them, increase the font size, correct? Right, I can even add the space between them, so on and so forth, right? Now I can get out, and then when I use this, I can extrude this and make a 3D object. But as you saw, that curve, that was a construction element, it had no effect. I could not extrude that or anything, right? So that's the nature of construction element. You can convert anything into solid a construction element just by clicking on it, and then on the left window that appears, if you check that one says for construction, it will be converted to a construction element. So that's one thing. The other thing is the grid. Okay, so you can choose to show or not show the grid, right? So for example here, if you remember, we had some sketch, and as you can see here, I do not see any grid behind the sketch, right? It's just blank. But if you go under tools and options, right, and then you have sketch, and then you have relations and snap. So this is for, if you say snap, sketch, snap grid, when grid is displayed. This is not showing the grid. This is what? This is basically snapping to grid point when the grid is shown. And I'll tell you what snapping to point mean. If you go under display, okay, then you probably don't see the grid here, right? So there should be a place here, although we can find an option here too under this eye, but there should be somewhere, if you remember, that might be enabling you to show the grid. And where is that? Here. Under document properties, there is this tab says grid and snap. So first you activate this to show the grid, right? And then since the snap to point, you activated that, let's see what happens. So now, of course, the grid is shown. And now I can, let's say I want to draw a rectangle, right? If you see here, when I move my mouse, the only points I can click and start the corner of the rectangle are only what? The grid points. I can only jump from one grid point to what? To the next, to the next. I can never click in between the grid points inside any of these small squares. Why? Because that option I activated, which is called snap to grid points or the intersection points. Okay, so when you activate that, you can never click in between. You can jump from one grid point to the next. But if you turn that off, look, if you go back and turn that off here, then I want to draw a rectangle. Now look, right, because the grid is displayed. But if let's see, let me go back 1 second. Turn that grid option off too also. So now if you look, you see, now I can click anywhere that I want because I turned off that option says snap to grid and when the grid is shown or not. Okay, so now I can click anywhere to anywhere. So that's snapping to the grid point. Then the other tools that allow us to modify our sketches are called sketch tools. So the previous ones, the circle, line, curve, all those, they are called sketch entities. But we also have sketch tools right next to them here on the top. And these give us extra tools to modify our sketches. Like one of them we have seen, fillet and chamfer, but there are more. We can do trimming, we can do extend, we can do convert entity, one of the very powerful ones. We can do intersection curve, offset, mirror, linear and circular pattern, rotate, move, scale, split, insert a picture. There are so many things, okay? So let's get started and see them one by one because I need to go over them. They're extremely important. And then we go through the rest of it. So let's go through them. And so here is a rectangle. If you remember, I showed you the options for fillet, right? So you click on the two edges, then provide a radius of a fillet, and then you can round it up. Correct? Round, not round it up, round it. And then you can click on chamfer, and then provide a chamfer, right? With the distance method or angle distance method. Correct? So these are two ways to get rid of a sharp corner. But there are other tools like what? Let's say I want to mirror something, right? So first I need an axis or center line. So I draw a center line here, let's say. And then I choose whatever want to be mirrored. So let's say all of these guys, I want to mirror them. Then I click on Command Mirror Entity, and then I choose my axis, right? Of course, you have to make sure when you choose your axis, it's not under Entities to Mirror. Actually, you have to click here first. This one says Mirror About, and then choose your axis. Okay, so the top ones are the entities to be mirrored. The bottom window is the axis of symmetry, and then there we go. Yes, so this is the mirror tool. There are other tools too. So, for example, let's say I want to create an offset of this guy, correct? So let me use a simpler thing for the moment. So let's say a circle. So let's say I want to create an offset of the circle. So I choose the circle, then I click on offset, and then I can provide the amount of offset. And so the gap between these two circles is 0.3, and it is drawn outside, but if you want it inside, you click on this one and say reverse, right? So you can draw it outside or inside, and then get what? An offset version of your total sketch. You can do linear patterns and circular patterns. They are very useful. So let's say here I want to repeat this circle. So I choose it and then click on linear pattern. And then it says along which axis do you want to repeat. So the default here is x-axis, but you can choose any other line. If you have any other line, you can choose that. Okay, and then you provide the number of instances and the gap between them. Right, so with the gap of 1.5 inches, I want 4 of them along X direction, and then along Y direction, you can also provide what? Some instances to you. So you can create basically a matrix, a rectangular pattern. Right, so, and each direction you can click on these arrows and reverse it. Okay, yes, and so there we go. I create a 4x2 rectangular pattern. So that's one of the ways you can do it. The other thing you can do is called a circular pattern. So you can basically pattern a sketch about a point. So I want this to be repeated in a circular manner. About, you need to have a reference point, and here the only point that is available right now is origin, but you can draw ahead of time another point and then rotate it about that point. That's one of the places that you said, where can I use points? Well, one of them is here. So I want to repeat it about this point. So I choose this guy here, and I say circular pattern it. It says about origin. So no, I want it about this point actually. Okay, and then you provide how many of them you want, and whether you want them equal distance or not. Okay, and so it calculates the angle for you, and there we go. You can have a circular pattern. Okay, so these are really good, and they save you a lot of time. Okay, so this is about some of these tools. What else do we have? So another thing we have is moving, scaling, repeating, and so on. So under this move entity, you can move something from one place to another. You can copy from one place, another instance somewhere else. You can rotate it, you can scale it, stretch it, and so on and so forth, right? So here, let's say I want to move this guy. So I click on move. Then it says how many units X and how many units Y do you want to move it. So I want to move it 1 unit X, and then I want to move it negative 0.5 unit Y. Okay, and there we go. Okay, so I moved it, right? Or I want to create a copy of that. So again, you provide the amount of X and Y offsets, so 2 inches in the X direction and negative 1 in the Y direction. All right, let's see. Oh, I didn't do it. Let's make sure. 2 and negative 1. There we go. So I could copy that. You can move. Just make sure you click on that green OK. And you can rotate any entity about any center, right? So to make it a little better visible, maybe I draw a rectangle. And let's say I want to rotate this. So I go here and say I want to rotate it. It says where's the center of rotation? I say origin. And then what is the angle of rotation? So you provide the angle of rotation, let's say 10 degrees, and then there we go. Okay, so you can do rotation of entities. You can scale them. So I choose this guy and say I want to scale it. And it says again about which point. So you choose the point of reference. Let's say this point, if it allows, and then you provide the scale, right? Whether it's bigger than 1 or less than 1. Or you can choose basically the origin, right? And then scale it. Now it depends where your center of scaling is. So if it's any point other than the centroid of the shape, then it's not going to fall on the top of the original one, okay? It's going to be outside of it. Why? Because the way this scaling is done, when you define a center for scaling, so let's say here I draw this rectangle, the same thing that I did, and then this point here is the center of the scaling, correct? Then this is how the scaling is done. So if you choose any point on this rectangle, let's say this corner, it measures the distance between this point and the center. If you call this D1, and then your scaling, you call it whatever you want, alpha or M. Then let's say this M scaling is bigger than 1, then it makes this distance D1, it make it equal to D1 times N. Okay, so it brings it here, and it makes sure that this distance is M times D1. So that corner comes here. Then the same thing happens to this point. Again, you connect with a line, and then whatever that line is, if it's D2, it's converted to basically M times D2, and similarly for D3 and D4, right? So it finds the centers and then the corners and then connect them together. Okay, that's why it's coming outside the object. Well, if it was here, the center, then it measured this distance, and let's say the scaling is 2, so it made this distance 2 times bigger. It made this distance 2 times bigger, this one 2 times bigger, and this one 2 times bigger. So your rectangle would look like this, right? Which has overlap with the original part, or they are basically kind of like concentric, basically. So I recommend, if that's what you really want to do, make sure your reference point is the centroid of the shape. And we'll talk about finding the centroids later. So some of the other things I need to mention are convert entity, intersection curve, and then trim and extend. These are nice things, so let's talk about them. So let's say here I have a rectangle, and then this rectangle also intersects with a circle like that, and then I want to trim these parts of the circle and rectangle that are inside and make it just one single closed sketch or profile. So I can use the command trim, and trim has different options for trimming corner, doing power trim, trim inside part, outside part. The one that I use the most and is the most powerful and typically does what you want is the bottom one, trim to the closest. And just click on the part that you want removed. So I want this removed, and then I want this removed. And there we go. Okay, so I use this trim command a lot because it is really powerful, and I can get rid of the parts that I do not need. Okay, so that's one of the things that I really like and use quite a lot. Another thing which, although you do not really need to use it, but could sometimes be a little bit useful, is the command extend. So here, let's say I want to extend this and bring it all the way to the other line and make these 2 points on the top of each other, coincidence basically. So how do I do that? I want to basically close the sketch. So one way is, of course, I grab this point, hold down and drag and bring it all the way, and there we go. Right, that's one way. The other way you can do it is here, you go under extend, and I say I want to extend this, and it says extend it to the next entity that it intersects with. So there we go, right? So you can do it that way, right? So that's quite an interesting thing. Now let's just try it also on a 3-point arc and see whether that works on a 3-point arc too or not. So here, okay, so I click on this and then I say extend. And you see it continues the same curvature until it hits the line. Okay, so this is extending, while if I just grab the point, then it might completely what? Changes the radius of the original curve, right? You see, I can make it bigger or smaller when I drag the point. But the extending does not change the shape of the curve. It keeps the same curvature and the same radius, just extended until it hits the next quantity. So in that term, I can say this is more accurate in most of applications than just grabbing the endpoint and continuing it until it touches the next entity. Okay, so it can be quite useful. The two other things that are really good and useful and powerful are convert entity and intersection curves. So convert entity is when you have a sketch on another plane and you want to project it onto the current plane. What do I mean by that? So let's say here I go to the front plane and then create a sketch, whatever you want. Then get out. And now I go, let me also show the front plane. I create a new plane and basically, I guess what I need is, let's make it at angle so that you see the effect better. So I add some line like this for rotation. And now I go to customize plane and say I want this plane to be rotated on this one, and I provide an angle. Let's see. Yes, that's good enough. So now I have this plane, plane 1, which has angle with respect to the front plane, and now I want to project that circle onto this plane. So I go to plane 1, go to sketch, right? And now I will click on this circle, and then I use what? Convert entity. When you can project, basically, that's what it does, project. It projected that circle onto this plane for me, and whenever you see this cube in a green window, that means that entity is projected. And you can clearly see it here. Okay, so this is the original circle. When I project it onto this plane at angle, what do I get? Of course, I would get an ellipse, right? Because they have angle. When you project a circle on any plane other than parallel with the original one, you will get an ellipse, right? So I got an ellipse, this one, projection of that. Okay, so this is called convert entity. What else? Another thing is intersection curve. That's another interesting thing. So let me show you that actually. That might be another interesting thing to do. So here I create an object from this sketch. And now let's say I want to cut that object with this plane and then get what? The intersection curve between this plane and that object, right? Yes? So I go to this plane, go to sketch, and then I go under here and then say what? Intersection curve. And say intersection with what? I say with the surface. And look, here we go. Right? An ellipse again. So you can intersect the plane or surfaces, planes with each other or surfaces with the plane and get intersection curves, or you can project a sketch from one plane to another. These tools are going to be extremely useful later on and when we get to them. So just wanted you to know about those. One other thing I want to mention is sketch repair, which is not really repair, it is actually finding the gaps. So let's talk about that as well, because that's important. And I guess then I can say I have covered most of these except for split and picture, which I'll show you. So, by the way, I'm now also showing you the sketch repair, okay, this guy. So I'm showing you this one as well. So sometimes you have a sketch and this sketch has some gaps, so it's not completely closed. And if the sketch is not closed, then for many applications, to convert them into a 3D feature, you cannot use them, right? So let's say here, I draw a profile, a pentagon, and I make these two endpoints very, very, very close, not completely on the top of each other, right? So when you zoom out and zoom to fit, you cannot see the gap. So you think like, well, I made it close. And it looks close. It's hard to see there is a gap here. And then you exit the sketch and then you try to use this guy and create an extruded object, right? But then you see this here, that it does not give me a solid object, actually it gives me a shell. Why? Because my original sketch is not closed. And when it's not closed, it's not going to give you a solid object. It will give you a hollow shell. That's the best that SolidWorks will give you. Okay? So you might wonder what was wrong. Why cannot make it completely solid? Well, because your sketch had a gap. Well, how can I find it? Especially if the sketch is quite large and it has too many corners. Should I zoom with this one into each and every one of them and make sure that those points are coincident or not? Or is there any way to find the gap? Yes, there is. You just need to click on this guy, sketch repair, and then say find any gap that is smaller than this dimension. So any gap less than 0.1 inch that I might not be able to see, go and find it for me. Okay, and you refresh, and it might be able to find it. If it doesn't, means your gap is probably bigger than that. How about 1 inch? Okay, so you have to see if you can find any gap smaller than that, and I guess this gap was, let's see if it's, wait a second first, it seems like they are merged somehow. What happened here? Oh, they are merged. For some reason I don't know they're merged. Let's make sure they are not merged. I don't know why they're merged, but they are. So here, clearly there is a gap. And now I use this again, say anything less than 0.1 inch, find it for me. And there we go. It should zoom around that area and tell you, hey, there is something. If there is more, then you click on this guy and it goes to next, 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 right? So once you find it, you know where you should zoom. And once you have that, you just drag this point and put it on the top of that, or you just, we'll see in a second that we'll multi-select both points by holding down Control and then use this one says merge. And you merge them and now it is good to go. And now I can use it and create a solid object like this. Okay, so that sketch repair is quite a nice thing. Okay, going back. So before I start talking about dimensions and relations, there is one nice more advanced thing. It's called equation derivative curve that I need to talk about. Oh, and I guess I forgot two more things. Yes, I just told them, but I forgot. Told you there was a split and add a picture. I guess I showed you add a picture, but I'll do it again, and I'll show you a split. Okay, so let me show you those before I forget. So as I said, the adding of pictures can sometimes be really useful for reverse engineering purposes, right? So for example, this is one of the things I did. So I made a part like this, and let's say you want to make our ERAU eagle, you might make a 3D part like that. So as long as the cross section is the same, I just right click here and save the image, right? And then I can come here and then go under insert tools. Tools, not insert, and then go to sketch tools and then go down and find adding a picture, sketch picture, and then insert that picture here, right, where you can now drag it to anywhere that you want. You can rotate it, you can scale it, or do anything, right? And once you're happy with it, now you can start drawing on the top of that, right? So you grab your Espy line, that's one of the other places Espy line is good. And then start clicking on these points. Correct? So if you are a little bit patient, you can easily get our eagle. Now, one thing I need to mention, that's good actually that I chose this example, is Espy lines, as I said, are smooth curves. So whenever you have sharp points, you should not use the same Espy line. So here you see when I reached this point, I did not continue this Espy line. I finished this Espy line by double clicking on the endpoint, and now I start a new Espy line. Because if I don't, then once I go to the next one, your original one will be distorted. Okay, let me show you. So here, look. I go to this sharp point, right? But I don't finish it. I continue here. And look. You see, here, I don't have the crisp and sharpness of here, because you had to make it smooth. And it could be worth when your Espy line is too long like this. If you continue that, it's not going to be nice. So again, I recommend as you go from, as you pass through each sharp point, you finish one Espy line and then start a new one, okay? That can give you crisp edges. Because with Espy line, you can never ever get sharp points. Espy line is meant to be smooth. So you see here, I'm just going from one to the next. Then you keep going. Okay, I'm not going to do all of this, of course, but just want to show you the power of Espy line and inserting a picture. And when you're done and you don't need this sketch anymore, this picture anymore, let me get rid of the grid and hide it. You don't need it, just click on it one time and what? Just delete it. That's simple. Click, delete. Done. Okay, so you're just down to the sketch, and then you can use it to extrude it and do anything you want. So that's inserting picture. The other thing I wanted to mention is splitting. So let's say here, I have an ellipse or I have any other shape, and I want to split this shape into two or several parts. So the split tool is not among these toolbar tools by default, but you can find it under Tools, Sketch Tools, okay? So you don't see any split here, but again, as I said, if you go to Tools, Sketch Tools, where you also found this Insert Picture, one of these tools is Split, okay? So there are a few tools here that you can see here, but you cannot see up here. You can go to Customize under Tools and add them to this toolbar, or you can just leave them there. The reason they are there and not here is because they are not as frequently used as these guys. So SolidWorks tried not to make your toolbar super crowded and super busy by adding every tool possible. But you can add them if you have use for them all the time. You might just add them, okay? So like the segment command is not there, okay? Or make path is not there. Or this direct conversion between construction geometry and construction elements basically is not there. So that's split entities. And then let's say I come here and I want to split this line at this point, right? And now if you look, you see this line is now broken into two pieces at that point. And then I can choose any of them, modify it, delete it, or do whatever you want. Yes, so it's just a powerful tool to get rid of a portion by splitting it exactly at the location that you want. Okay, now I said there is this advanced tool called equation-driven curve. So sometimes you can create curves that are equation-driven. Not every curve is simply a circle or a rectangle or something. Sometimes you need curves that are equation-driven. Like, for example, you might need something related to a sine or cosine. Well, there is no sine or cosine command here. Or to make it more complicated, you might need the chirp signal, right? X sine of x or x sine of x squared or something like that. Well, if you want those curves, you have to use this equation-driven command, okay? And you can make then arbitrary functions. And you can make it explicit or parametric. So let's say here, and where is that? So if you go under Espy line, then you have equation-driven curve. And if you say explicit, then the y is directly a function of x. If you say parametric, then both x and y are going to be functions of the parameter t. So let's say I directly know the function of y versus x, and that is x times sine of x, okay, right? And then x goes from like 0 to 4 times pi. And by the way, SolidWorks knows pi. So if you just say pi, it knows it's 3.1415, okay? So it recognizes pi, it has the function sine of x. So it's quite similar to MATLAB here. And look at that. Yes? Here we go. So you can basically draw any function that you want and you might need. Okay, so now that we know how to draw sketches, how to modify them, repeat them, pattern them, break them, trim them, and so on and so forth, project them, right? Now it's time to make them fully defined. It's time to provide their dimensions, their locations, and anything they need to completely specify their details in the sketch plane, okay? That's called basically constraining a sketch and providing dimensions and relations. How do we do that? Well, one way is to add dimensions, whether linear or radial dimensions. The other one is to provide constraints. Like what? Like make a line horizontal, vertical, make two lines parallel, make two lines equal in size, fix a line, make one line collinear with another, make a curve and a line tangent, two curves concentric, two curves corradial, 2 points coincident, or a point and a line coincident. make one point the midpoint of a line, make two objects symmetric with respect to an axis, right? Make two lines perpendicular. So these are all sorts of constraints, and I'll show you several of this, as well as what? Adding dimensions. Okay, so let's talk about them, and then although I mentioned driven versus driving, I'll mention it one more time for you, just to refresh your minds. And then once you know these three guys, you can make all of your sketches fully defined, and then they are going to be perfect and good to go. So let's say here, starting very simple, I need to draw a rectangle. So I draw a rectangle. Now, as you see, all of the lines of the sketch are dark blue. Dark blue means they are underdefined. They are not completely defined. Why? Because I just can grab them and move them around. So the locations are not fixed. And I can grab the endpoints and resize them. So the sizes are not fixed. The only thing these guys have are some constraints which says they are either horizontal or vertical. If I delete these guys, so if I just click on this green window and then use delete from keyboard, now this line is not even constrained to be horizontal. So if I grab one point, I can give it an angle. Yes? So there are some auto constraint that SolidWorks gave me, horizontal, vertical, but it's not going to give me everything. I have to add something to make sure this is perfectly defined. So here, let's say I know all of the edges are vertical and horizontal. What do I need now? So the first thing is the size of the rectangle. So you click on this tool here, Smart Dimension, and then you click on one of these two horizontal edges and provide the dimension. So you click outside so that this window appears, and then type in the dimension. So let's say this is 6 inches and enter. And then you click on the height, and let's say this is 4 inches, and you enter. Okay, so I first provided the dimensions. If you want, at any point you can change them. Just click one time on them to this window, and then you type the new number and enter. Right, so you can easily provide dimensions. Good. So now if you drag these guys, the points or edges, you can only move it. You cannot resize it anymore because the sizes are fixed. So now how do I locate this? Okay, when you want to locate it, you have to locate it with respect to something that is fixed itself, that is completely defined itself. The only thing I have right now is origin. I don't have any other sketch entity or anything that is fully defined. The only thing I know, which is perfectly known, is origin. So if I provide the offset of these edges with respect to origin, that could get my job done, right? Let's say I want the origin to be the center of here. So what should I do? I click on the dimension again. I click on this vertical edge, then I click on origin. And then I say, well, this gap is half of 4, which is what? 2? Yes? Then I click on this edge and click on the origin again. And I say this gap is half of 8, which is what? 4. And now if you look at my sketch lines, they are all black. When something is black, it means they are fully defined. Now you cannot drag them at all, because the sizes are fixed, the location is fixed, okay? This is ideally the type of sketch I expect everybody to make in this class. Never leave any entity just dangling up in the space, okay? Make sure the location and the sizes are all fixed, okay? So that's one way to make your sketch what? Fully defined. Now, if you go one step further and treat SolidWorks as if it's stupid, so basically provide more dimensions than needed, SolidWorks is not going to like it. So here you said this height is 4 on the right edge. Then you go here and click on the left edge and say, hey, this is also 4. Well, he knows this is 4. It's a rectangle. So you are providing a redundant dimension. And when you do so, then CATIA color directly goes to yellow. Yellow means now you are providing more dimensions than needed. You're over defining your sketch. Then it asks you, hey, do you want to make this dimension driven? Driven means passive, means it has no effect on the sketch. It's just there for information, and it's redundant, but it doesn't hurt. And the color of a driven sketch is gray. Okay, so if I say yes, then it doesn't pick on you anymore. It just makes this gray. Now you cannot double click on this and change it. When you double click on this, it says, hey, it's driven. You cannot change it. You can make this guy, which is independent, a driving dimension, and it's black. You can click on this one and then what? Change it. And when you change this, the other one will change accordingly. Right? So driven ones are just reflective, passive. They are not going to do anything. But if you, when you did this, if you say, no, I want it driving, check this one, then SolidWorks is not going to like it, because now you have two dimensions. Each one of them you can change, and they are the same thing and redundant. So SolidWorks is not going to like it and show it as yellow, and it's not going to let you use this yellow sketch to create, let's say, a cube, extrude it. SolidWorks does not allow you to use over-defined sketches. It allows you to use under-defined sketches if you want. If your sketch is blue, you can still extrude it and make it a cube, let's say in this case. If it's fully defined, no problem. But if it's over-defined, SolidWorks is not going to allow you to use it. So make sure it's never over-defined. Never do it over-defined. If anything is redundant, get rid of one or some of them and make sure nothing is over-defined. So I right-click on this and delete it. This is good. I can extrude it. Even again, if it was not completely defined, so you had some blue entities, that is fine. Still, SolidWorks allow you to use it for 3D creations. Although it's not preferred and ideal, but still it allows it. But again, if it's yellow, SolidWorks will not like it. So never make it driven. If it's redundant, if you want to have it for information, make it driven. Although I don't suggest having any redundant information. So what's the point of driven dimensions? I'll show you later. Sometimes if you are in Sketch and you want to look at the dimension from another sketch, not in the same sketch, you might add a driven dimension for your references. I'll show you the application later. But in the same sketch, try not to have a driven one. So that's driven versus driving, and then adding dimensions that I mentioned for you. I mentioned about automatic constraint that SolidWorks adds to some of your sketch entities, like this horizontal, vertical. Now it's time to talk about geometric relations. These guys can also be used in place of or in conjunction with the linear dimensions or the dimensions in general, could be radial dimension, to fully define the sketch. So let's say in this case, I don't want it centered at origin. I want one of the corners to be at the origin. So I want this bottom left corner to be at the origin. Well, how can I do that? Well, one way is to provide zero offset, right? So I say, hey, this bottom edge with the origin has zero offset, and then this left edge with the origin also has what? Zero offset. Yes, but that's quite dumb, providing two zero dimensions. So a better way to do it is using constraints. So you hold down Control, because you want to select more than one thing. You hold down Control, first select this corner, then select the origin. Both of them go light blue, and then on the left window, it shows you all of the options that are possible, and the one you want is what? Coincident on the top of each other. And there we go. Done. Whenever you see the symbol here, an intersection with the circle in green, that means some stuff are coincident there. So that's another way to make something coincident, right? Good. So let's talk about other type of geometric constraints. So let's say I have a circle here, and so the center is coincident with origin, so the location is fixed. I click on the dimension and provide the diameter. Now I want another circle, so I draw another circle. And I want this circle with this one to be what? Concentric. So I hold down Control, select both of them. And then if I make them corradial, they will be on the top of each other. If I make them concentric, the centers will be at the same point. If I make them tangent, then one is going to be internally tangent to the other. So look, if I say tangent, that's what's going to happen, like internal gears. If I say concentric, then they're what? They're going to have the same center, right? So this is another way to basically provide a constraint to your sketch. Now, what else? Sometimes I have this circle. You see here, I make this circle, and I want to make sure the circle's center is in the same horizontal line with the center of this circle. So I hold down Control, select this center and this center, and then I say I want them to be in the same horizontal level. And then I also want this to be the same size as this one. So hold down Control, select this, select that, and then I say what? Equal. And it makes them both the same size. And then all I need to provide is center to center distance. Correct? And that makes the other one also fully defined. Okay, so you see how I'm using a combination of geometric and geometric constraints and dimensions to make my sketches fully defined, right? So I showed you several of this. Fix is not a good idea. Fix means just basically glue it back to the background without me providing any size or any dimension. Whatever it is, in wherever it is, just keep it and not mess up with it. So fix is not really a good idea unless you temporarily want to not provide dimensions and constraints, yet you don't want anything to happen to that entity. So you drew something, you don't know where you want to put it. You just don't want anything to just mess up with this. So you just click on it and then say, hey, fix it for me. Use the anchor. And you see it is fully defined. You cannot do anything to it. But it doesn't mean you have provided dimensions or locations, okay? It's just basically saying, hey, whatever it is, wherever it is, don't touch it. Okay, so I guess I mentioned adding geometric relations, and there are more that we're going to go through, as I said, in this course. Adding dimensions, the meaning of different colors, light blue, dark blue, red or yellow, and black. So we talked about this. Now, as I said, there is a type of sketch in SolidWorks called 3D sketch, and these are basically 2D sketches for which during the drawing you can change the sketch plane so you make it 3D, right? So let's say you want to make a 3D structure like this, which by the way we'll do this in the classroom, but if you see, this sketch is not done all in the same plane, right? So this part is in one plane, this part is in another plane, and then the end of it is in another plane. So you change 3 planes basically when drawing. And we're gonna, as I said, we have several practices for classroom. So we have this one, this one, this one. And then for 3D sketches, as I said, we have this one. And it does not have all the options for drawing sketch entities. It's mostly lines, circles, arc, Espy lines, point, and rectangle. So you cannot draw ellipses and some other things. But if you use tab, you can go basically from one plane to another and then make it look 3D. Okay, and I'll show you an example. So here basically I create a new part, and then under the sketch tab I can basically have the sketch 2D, or if I expand it I can do a 3D sketch. And I can start on any plane that I want, right? So I can, let's say, start on the top plane, and then I can leave it in isometric. So it's better to leave it in isometric when you draw a 3D sketch instead of looking perpendicular to that plane. And as you see, some tools are off here, so not all of the tools are active. So if I just use the line for the moment, I draw a line here along the z-axis. Then I move here along the x-axis, right? So right now I'm just drawing it on xz, which is the basically top plane, right? So I'm still going on the xz, correct? Now here I want to change my plane. So I want to go on a vertical plane now, like on the right plane, correct? So although here it looks like I'm going up, but I'm not really. I'm just moving on a combination of x and z. So my plane has not changed. It's just diagonal between x and z, although it looks like it does, but it does not. And you can see my current plane here, right? It is shown next to my pencil. So right now it is on xy plane. So I can go on xy plane, right? Let's say I can continue here. If I want to go back to the xz plane, which was what I had, first I click on the tab, right? So here I do tab. So this is what I had. It was on xz plane. But if I want to go on YZ plane, which is the front plane, I use tab from the keyboard, and now it is really going upward. So I go on the y-axis. Now I can continue on the z-axis. Okay. And then here. And then let's say now I want to go on the XY plane. So I use tab again. And I can change my current plane, and now I can keep going, and when I'm done I double click. Okay, so if I rotate this for you, you can clearly see that it is not a 2D sketch. Okay, so it's clearly a 3D sketch, and of course I can still use the dimensions and provide the dimensions, right? Okay, so I can still provide my dimensions here. I can still use Chamfer and so many other tools, right? So you can see here, I click on this edge and then this edge and provide a radius for fillet, right? I can do it here. And so on and so forth, okay? So I can easily so that was too big for it, so yes. Then here. Okay, so I can do whatever I want, and again, as I said, this sketch is a 3D sketch. Now you might wonder what's the use of this. So it is used for some furnitures, and it is used for 3D pipes and some other applications. So we'll see the applications later on, but this has its own applications. Okay, instead of you each time you define a new customized plane and move from one plane to the next, to the next, to the next, you can just keep using tab and move on and basically draw your 3D basically wire or 3D sketch. Okay, so this command can be quite useful. Okay, so I guess I covered most of the stuff that we need for the sketch as far as I know. Sketch entities, sketch tools, finding the gap in the sketch, right? Projection, view toolbars, closing the sketch and keeping the additions, discarding the additions, right? Creating a sketch, creating modified planes, and so on. One of the things that might be interesting is this guy here, display and delete relation. So if you click on this, any constraint, okay, or distances that you have made in this sketch can be shown in one single window. Then all you need is, if you don't want that, because sometimes you make something over-defined or conflicting dimensions or constraints, and you really don't know what is what, so it's sometimes a good idea to look everything, and when you click on each one of them, it will be highlighted here, right? So this horizontal one, you see, it is highlighted for you, or this vertical one, you see, it is highlighted for you. And then if you don't like that, you can just either suppress it or delete it, or if you want, you can delete all of them, right? So you can just simply say delete all and get rid of all of these.